Welcome to another one of PCB's educational videos. My name is Mark Valentino. I work as a product manager here at PCB in the acoustics department. Today we're going to discuss the differences between traditional externally polarized microphones, also called 200 volt microphones, and modern pre-polarized 0 volt microphones. In 98% of test and measurement applications, both a traditional externally polarized microphone and a modern pre-polarized microphone will perform the job equally as well. Both of these styles of test and measurement microphones operate on a capacitive design. You have two surfaces, one being the diaphragm and the second being a backplate. The microphone has a specific distance between the backplate and the diaphragm under static pressure. Changes due to the pressure will make the air gap between the microphone's diaphragm and backplate change and thus form a change in capacitance. To measure the change in capacitance, a polarization voltage is applied to the backplane to form a transducer. There are design differences between the two types of microphones. An externally polarized microphone utilizes a separate 200 volt power source to polarize the backplate. A modern pre-polarized microphone has a thin electric layer placed on top of the backplate where the polarization charge is stored. You can think of this as putting an external 200 volt power source directly on top of the backplate. What this does is allow for a common standard 2 to 20 milliamp constant current supply or signal conditioner to be used as a power source. It's very difficult to tell the differences between the microphones just by looking at them. Model numbers are etched on the microphone to show that, but also with a pre-polarized microphone, we etch two rings around the bottom of it to tell that you're using a pre-polarized microphone. There are application differences between the microphones. Traditionally, externally polarized microphones have been around for longer and are easier to manufacture. There tends to be more 200 volt models available. The externally polarized microphones also can go to higher temperatures, but note that they need to use a preamplifier with the microphone, and usually the system is limited by the temperature rating of the preamplifier. 200 volt preamplifiers have a higher output voltage also, 14 volts peak versus 8 volts peak for a pre-polarized preamplifier. This allows them to perform at a slightly higher amplitude with a similar sensitivity microphone. In almost all applications, though, engineers tend to go with a smaller diameter or less sensitive microphone to allow them more headroom when they need to get to high amplitudes. Modern pre-polarized microphones do not require bulky power supplies and are better for portable applications. They are becoming increasingly popular for portable sound level meters or for use with laptops. Because of their design, 0 volt or pre-polarized microphones offer better performance in very humid applications. The major deciding factor why the majority of end users are transitioning from 200 volt or externally polarized to pre-polarized microphones is the cost per channel. Externally polarized models require an expensive 200 volt power supply. This is typically in the range of 5 to 7 times that the cost of a single channel pre-polarized signal conditioner or power supply. Plus, more and more DAC systems now have this power supply built in for signal conditioners for pre-polarized microphones. Another reason is the cable cost. Externally polarized microphones require 7-pin cabling and LEBO 7-pin connectors, where pre-polarized microphones utilize coaxial cables with BNC 1032 microdot or SMB connectors, which are typically about 1/7 the cost of the externally polarized cables. So by the time you add in the system cost for the cabling and power supplies, the cost per channel is much lower for a pre-polarized microphone system. Besides a lower cost per channel for pre-polarized microphones, you can also amortize your setup costs over other tests. Externally polarized power supplies and cables can typically only be used for externally polarized microphones, whereas pre-polarized power supplies and signal conditioners and cables are flexible and can be used with other transducers. For example, you can use them with accelerometers, pressure sensors, force sensors, and other sensors that require that same 2 to 20 milliamp constant current supply. Plus, if you have a multi-channel signal conditioner or power supply with a pre-polarized system, you can run your tests simultaneously and multitask and run your vibration test with accelerometers in one channel while you run your sound test with a microphone in another channel. So if externally polarized and pre-polarized microphones both do the job the same in 98% of the applications, which is preferred in today's marketplace? It's my personal belief that within the next decade, 95% of all the mic systems will be pre-polarized design due to the significant per cost per channel advantages over the externally polarized and because of the flexibility. End users will typically order the 200 volt models as replacements for existing systems or for when a pre-polarized model is not available. In summary, there are two types of designs for test and measurement microphones: externally polarized, also called 200 volt, and pre-polarized 0 volt microphones. Traditionally externally polarized microphones are easy to build and have many models that have been offered through the years. These traditional microphones are more stable at high temperatures around 150 C, but require preamplifiers that are the limiting factor with how high they can go in temperature. These preamplifiers start out at 60 to 70 C and go up to 120 C. Modern pre-polarized microphones are better suited for humid applications. They're also better for portable applications. Modern pre-polarized microphones offer significantly lower cost per channel solutions because they utilize low-cost power supplies, low-cost cabling, and they also offer the flexibility of being able to be used with other sensors that use similar cabling and power supplies. You could also use a multi-channel signal conditioner to run tests at the same time. So in most cases, both these microphones will work well in your application and output the same accurate results. For more information, visit pcb.com/acoustics or give us a call at 1-800-828-8840.